Hello, this is our FYP proposal presentation. This study is assisted by our supervisor Dr. Nazahatul Sahima Muhammad Yusuf. The title of this research is The Performance Efficiency of Water Supply System in Malaysia using Data Environment Analysis Models. Let me introduce our team. My name is Muhammad Nazmi Irfan bin Muhammad Rizwan with my metric number 2020960977 and I will be the first presenter.
Assalamualaikum, my name is Farah Irsalina with my metric number 2020963619 and I am the second presenter.
Assalamualaikum, my name is Nur Ainada Binti Ismail with my metric number is 2020974441 and I'm the third presenter.
Introduction. What is a water supply system? A water supply system is known as a water supply network where a system of engineered, hydrologic, and hydraulic elements that provide water supply. The National Water Service Commission (SPAN) states that Malaysia depends on water supply from reservoirs, which are from rivers and storage dams that contribute 81.3% and 17.4% of the total water supply respectively. Okay, let's move on to the problem statement. In 2021, Selangor presently faces 68 hours of water supply disruption due to the maintenance of removing and connecting new pipes, which this indicates that the water supply system at Selangor is still inefficient. In 2020, IFHAP mentioned about dry weather where water shortage in catchment area could have an adverse impact on water supply delivery to customers. When water supply shortage is critical, treatment plants are forced to shut down. According to an article from the Federation of Malaysia Consumer Association (FOMCAM), Nur Imani said that during festive season, water supply will be 5 to 6 times greater than usual, and this is because of high water demand during it. This research will be conducted in Malaysia, which will be involving 40 states, which known as Decision-Making Units, DMUs. The first objective for this study is to determine and compare the efficiency score of water supply system of 14 DMUs using CCR and BCC BEA modules. The second objective will be to identify and suggest the best water supply system of 14 DMUs using super efficiency model. The third objective is to improve the inefficiency of water supply system by states in Malaysia using SBM DEA module. Significance of the study. In this research, it will be important for water companies to provide the best services, while in the academic field, it will be useful for future use. Furthermore, in this research, it will be a guideline for companies in Malaysia to reduce water demand and complaint from the consumer. Last but not least, this study will also benefit other states which are inefficient in water supply system at the current moment. This study will use the data from the Malaysian Industry Guide in 2018, which is published by the Malaysian Water Association, which includes the 14 states. DEA module will be applied in this study, which implies the use of CCR, BCC, super efficiency, and SBM module to evaluate the performance efficiency of water supply system. The input and output variable have been identified and chosen to provide a better efficiency score. The input variable are the operating expenditure measured in ringgits, while the raw water resources and water production is measured in million liters per day. The output variables are the pipeline measured in kilometers, the revenue measured in ringgits, while the non-revenue water measured in million liters per day. For this study, the best resource allocation will be verified and determined between the DAA modules, and it will be recommended for the water supply companies to improve their services to be better.
Thank you, Nazmi. I'm Farah Irsalina and I will continue with literature review. First, what is DAA method? DAA or Data Environment Analysis is a data-oriented approach for evaluating the efficiency performance of a set of entities called the DMU or Decision-Making Units. DAA consists of two types, which are Input-Oriented Model and Output-Oriented Model. According to Rajasekar and Teo 2014, Input-Oriented Model focus on operational and managerial issues and minimize the input for a desired level of output to be achieved. While Output-Oriented Model is correlated with planning and strategy and also maximize the outputs while input kept at constant level. Both input and output-oriented models seek to maximize the outputs, minimize the input, and finally maximize the efficiency score. Okay, next, why DAA method is chosen? The DAA method was chosen because to measure the efficiency of water supply systems in Malaysia and also referring to the previous studies done by the researchers. First, study done by Nobazura et al. 2018, Nariman and Azhar 2017 and Lombardi et al. 2019 was using the DAA. Last one is study by Hadian et al. 2020 was using Marquis Productivity Index and DAA. Okay, next is which models in DAA method are chosen. In this study, we have chosen 4 types of models under DAA, which are first, Chance-Cooper-Rots model or known as CCR model. This is the first DAA model suggested by Chance-Cooper and Rots in 1978. The second one is Banker-Chance-Cooper or also known as BCC model. This model extended by Banker, Chance and Cooper in 1984. These two models are used to measure the efficiency of water services and to compare which models give the best results. The third one is Super Efficiency or SE model. This model was introduced by Anderson and Peterson as a ranking method to differentiate the DMUs. Super Efficiency model will rank all the efficient DMUs from the results gained in CCR and BCC models. The last one is Slack-Based Measure or known as SBM model, which is a non-radial model proposed by Thun 2001. SBM model is used to suggest or give the recommendation for the inefficient DMUs to improve their services in the future, while the efficient DMUs will be set as a benchmark for the inefficient water services. Next, the studies based on DAA models that have been done by the previous researchers in water supply systems. First, the CCR model, a study by Nobazura et al. 2014, which used both input and output-oriented and study by Munisami 2009. Next, BCC model was used by Nariman and Azhar 2017 and Dong et al. 2018, which used BCC input-oriented model. The third one is Super Efficiency model, a study done Mehdi Lozat and Roshdi 2014 and Berg and Lin 2008 used SE input-oriented model. The last one is SBM model. Research has been done by Jiang et al. 2019 using SBM input-oriented, while study by Nobazura et al. 2018 using the SBM input and output-oriented models. So, as a conclusion, from the 4 DAA models, we have decided to use CCR, BCC, Super Efficiency and SBM input-oriented models in our study to measure the efficiency of water supply system in Malaysia. This is because, according to Coeli and Walding 2006, the use of input-oriented is to minimize the amount of input spent per output unit. For example, our purpose is to minimize the operating expenditure while increase the revenue of the water services. And next, to provide services to a specific geographical area and number of consumers. For example, to supply water in rural areas which known as a place that hardly to get clean water and increase number of consumers that receive clean water while maintaining less operating expenditure. Okay, the next chapter is methodology will be discussed by Ain Nadia. That's all from me. Thank you.
Thank you, Farah. Alright, I will continue with the methodology. I want to explain about the input and output that had been used in this study. Multiple input and outputs are used in providing the best allocation and suggest the best result for a company's improvement. Therefore, the selections of input and output variables are based on previous research, such as Hardian et al. 2020, Norbaizura et al. 2018, Nariman and Azhar 2017, and Norbaizura et al. 2015. After analyzing the previous research, the chosen input variables are OPEX, raw water, and water production. Meanwhile, the chosen output variables are pipe length, revenue, and non-revenue water, since these input and outputs variables are commonly chosen by previous researchers. Next part is about data collection. This study employs data from Malaysia's Water Industry Guide MWIG 2018 for the efficiency of water supply system evaluation. The total DMUs that will be estimated is 14 states in Malaysia, which covered Peninsula and East Malaysia. The data is shown in this slide. Okay, next I will explain about the methodology phases, where in this study we have 3 phases. The first one is phase 1, where we determine and compare the efficiency score of water supply system of 14 DMUs using CCR and BCC models with input orientation. In this phase, we are measuring the performance efficiency of water supply system between 2 models. Then, the result from the both models will be compared to find which model gives the best measuring score, and the model, either CCR or BCC, with the highest number of efficient DMUs will be chosen. The next phase is phase 2, where we identify and suggest the best water supply system of 14 DMUs using super efficiency input-oriented model. This model will be implemented in this phase to find the most efficient DMU with highest efficiency by ranking all 14 DMUs in order to be set as benchmark for other water supply system. In this phase, we use the best model from phase 1. The most efficient DMU is the one with the highest efficiency value. Last phase is phase 3 will be implemented to improve the inefficiency of water supply system by state in Malaysia using SPM model. We will identify which DMUs are inefficient from the result in phase 2. Therefore, the inefficient DMUs will be improved by using SPM input-oriented model, where this model gives the recommendations for the inefficient DMUs on how they can improve their water supply system. The last part is about the software that will be used to calculate all 14 DMUs, and we use Lingo, where Lingo is a computer software which is designed to solve problems faster, easily, and more efficiently. The language of Lingo modeling allows expressing the model in a straightforward, intuitive manner using summation and subscripted variables. That's all from us in presenting our proposal. Thank you.